Hello judges, we are from St. Aloysius to Highschool, Indonesia. First of all, let us introduce ourselves. My name is Adelia Diandra Darmawan.
My name is Stella Krisni Karlina.
And my name is Vasya Yusrin Janino. So today we are going to make something useful out of waste for our life.
As necessary, prepare the fruit peels, water, and brown sugar. Fruit skins should be divided into smaller pieces.
In order for brown sugar to dissolve easily in water, it is also chopped into little bits. Stir the water with the brown sugar in it until it is completely dissolved. Likewise, add the fruit skin that has been diced into little pieces to the mixture of water and brown sugar.
Keep stirring until everything is well combined. Then secure the container's lid until all parts are airtight. The compilation of ecoenzymes will take 3 months. We also conducted a survey of the waste in school areas for weeks and got the following data. We decided to use some inorganic waste that we found to make bio-batteries as an application in the use of ecoenzyme, one of which can conduct electricity.
In order to enable batteries to produce currents and voltages, environmental enzyme can be utilized as an electrolyte. Since ecoenzymes have an acidic pH of 2, they can be categorized as electrolytes.
Ecoenzymes and biobatteries made from ecoenzymes are used to convert both organic and inorganic waste into something more useful.
In order to create a biobattery, inorganic materials such as cans, unused styrofoam, acrylic containers are used as a vessel. Copper wire and tape magnesium are used as the battery compartment.
Use ecoenzyme liquid with a pH of 2 until 4 to fill the battery. Here we use ecoenzyme liquid with a pH of 2. We also use drugs of ecoenzymes.
This biobattery is based on the voltaic cell concept, with a copper wire cathode, a magnesium-based anode, and an ecoenzyme fluid and drugs as an electrolyte. The first step is to pour the drugs and ecoenzyme liquid into the used cans. The copper wire and magnesium tape are then scrapped to make them conduct electricity, because there is a coat of paint that prevents electricity from flowing.
Wrap the tissue around the copper wire so that the cathode and anode do not touch each other. The next step, wrap the magnesium tape around the copper wire that has been coated with tissue. Next, place the assembled copper wire and magnesium tape in a used can that already contains liquid and ecoenzyme drugs.
To test the battery, place it in an acrylic container that has been insulated with styrofoam. Connect it in series and measure the resulting voltage.
In the first experiment, the biobattery circuit produces a voltage of 5.25 volts and can turn on a small lamp very brightly.
The circuit used is a series circuit. The concept of the series circuit is to connect cathode bottle 1 to anode bottle 2, anode bottle 2 to cathode bottle 3, and so on.
This is the illustration of series circuit biobattery. This picture shows there is a battery consisting of a copper cathode and a zinc anode, which the cathode and anode are all connected in series, and if they are paired with the lamp, they will turn the light on brightly, which indicates that the biobattery produces current and voltage. To find out changes in current and voltage in the battery, we try to measure this biobattery every 40 minutes for 10 times. This is a graph of current versus time and voltage versus time.
So, from this graph, it can be concluded that the longer time taken, the smaller the current as well as the voltage generated by the biobattery. For our future works, we hope to be able to test different circuits and conduct experiments to learn more about the variables that affect the voltage produced in order to design a circuit that can generate high voltages. So, that's it for our presentation and
Thank you, bye-bye!